This is Geometry Lesson 4-2, Determine Similar Triangles. This is what we're up against. Let's zoom in here. Today's date is Thursday, Friday. I'm recording this in advance, so it's actually Friday when you're viewing this, January 29th, 2021. Our objective today is to determine if two triangles are similar using the angle-angle theorem and the side-side-side theorem. And you've seen the side-side-side theorem in a different form before in Unit 3 with congruence. So the way that I want to start this lesson off is remember what your congruency criterion were for last unit. And again, this is congruency criterion versus similarity criterion. So what were your theorems? We had, this one, right? We had side-side-side. We had angle, angle, side. We had side, angle, side. And there's one additional one. And there's actually a few extra ones. I'm just trying to remember. Side, angle, side. There's angle, side, angle. That's the last one I was trying to think of. We also talked about this one very briefly, HL. This was a special case if you had a right triangle. But we didn't talk about him in depth, or her, I don't know what the gender of that theorem is. Let me talk about similarity criterion. So down here, maybe I'll do a special color, we have the side-side-side criterion. We have the angle-angle-side criterion. We have the side-angle-side criterion. We have the angle-side-angle criterion, and the angle-angle criterion. Again, we don't really have the hypotenuse-leg criterion for similarity. So I will be talking about this before side-side-side because it's so new and kind of easy. But I want to talk about the differences between the two criterion. So when you're using these theorems to prove that triangles are similar, they're basically the same thing. As long as you have three sides that are not congruent, then you are going to be okay. So corresponding angles, every time that you see the letter A here, I'll just put a capital A, those A's have to be the same. They're congruent. So as long as the angles are congruent, that's exactly what it was for congruency. But for similarity, the side lengths, whenever you see the letter S, they don't have to be congruent. Obviously, if they're congruent, then they're also similar, because congruent is like a square, and then similar is kind of like a rectangle. That's a bad analogy. Let's ignore that. But it's a less severe restriction, and they just have to be proportional. So let's use this definition, and it's not really a definition, it's just a way to distinguish between the two different criterion. So if I know that the measure of angle A is equal to the measure of angle D, that means this angle have the same measure, then and I know that they're similar triangles, then I know that angle B must be the same measure as measure E. Similarly, the measure of angle C, U right there, are equal to that measure of F up there. Pretty straightforward, pretty easy. This is where we get a little bit trickier, though, and this is kind of why I was preparing everyone yesterday for these, I was going to say fractions, but ratios, these rational equations. If I know the ratio of DE to AB, I know this, maybe I can color code this better, this red length right here to this blue length right here, if I know that ratio, then that should be the same ratio as this leg right here to this leg right here. The short leg to the, or I guess I have to be careful about short and long. The short leg of the big triangle to the short leg of the small triangle is the same thing as the long leg of the long triangle to the long leg of the short triangle, the small triangle. Getting my words all mixed up. Main thing that you need to know here is that these inequalities are the same thing. So I have F D over CA. I wanted to change to blue there, over CA, and that is equal to the ratio of the hypotenuses together. So like if I do FE, the ratio of that hypotenuse should be the same as all these other ones. So ratio of hypotenuse, that's the big hypotenuse over the small hypotenuse, that's going to be CB. As long as you're talking about the corresponding parts, so corresponding parts meaning this hypotenuse and this hypotenuse, and make it into a ratio, then you're doing this correctly. And again, all of these ratios need to be the same ratio. Like if the ratio is 3 to 1, that means the hypotenuse here, if I multiply by 3, I get this. The same thing happens over here. If I multiply that length by 3, I should get here. If I multiply this length by 3, I get here. All of these ratios are the same. And this number that they're all the same has a special name. That ratio is known as the common ratio. No, that is the scale factor. I'm thinking of algebra, sorry. This is scale factor. Scale factor. Yeah, in algebra it has a different name. In geometry it's called the scale factor. All right, so we've seen this symbol before. This thing right here means similar. So the question is asking, is triangle ABC similar to triangle DEF? And again, you have to use these kind of two definitions now with all of these theorems to figure out, is this true? And really I'm kind of paying attention to the equations here. Are all the angles the same? If all three of these angles are the same, then they are congruent. So check. I have 43, 43, looks good. All right, then I have 84 and 81. Oh no, they're not the same. These triangles, they look the same if you just eyeballed it, but they're not quite the same. So the answer here, I like typing because it makes my handwriting look better. No, because the angles are not all the same. The angles have to be the same in order for them to be similar. All right, and that kind of brings us to the logic behind the angle-angle theorem. Again, I said if all three angles are the same, then they are similar. Well, the thing is, for a triangle, if two angles of the triangle are congruent to the other, then the triangles are similar. Why? We only need two angles, Mr. Snell? Didn't you just say up here we needed three? You're right, but you can always figure out what that third angle is. For example, if I told you, if I have a triangle here that was, I'm just going to make up numbers here, 80 and 50, and I told you this triangle over here was 80 and 50, you know what this angle is right here. It's obviously not even close to being drawn to scale. You know this angle because all three of these angles must add up to 180 degrees. So you could figure out that remaining angle and say, okay, well, 180 minus 80 is 100, 100 minus 50 is 50, so this angle must be 50. Oh, by the same logic, that angle must be 50 as well. And yes, all three angles are the same, and therefore we can conclude that the two triangles are congruent. But the thing is, the shortcut is you only need two angles for a similarity criterion. Kind of nice. It leads to some tricky problems though. So in example 2, I'm going to show you one of those tricks. Alright, so I'm using the angle-angle theorem obviously because I want to practice that. So using the angle-angle theorem, which of these blue or red triangles are similar to triangle A? So given A, is it B, C, both, or neither? Okay, well look, we have 87, 53. Oh, 87, 53. Answer C, right? No. You have to be careful. It might be C, but let's check, because you always want to find that third angle. So let's go ahead and find that third angle. If I add these two together, we'll see 87 plus 53 will carry. That's going to be really 60 plus 80. 60 plus 80 is 140. And then subtract from 180, this angle must here be 40 degrees. And now it's much clearer. Look, I have 87, 40, 87, 40. Again, I only need to match two angles, and I know they're congruent. So B and A, this black triangle A and this blue triangle B, are congruent because they have two angles that are the same. And this black triangle A and this red triangle C are the same because those two angles match. And in fact, if I were to draw all of the angles for all the triangles, you don't have to do this. But you'd say, okay, well, that's 53 over there, and this is 40 degrees down there. Then you can say, oh yeah, all three angles are all the same. They might be scaled up, they might be scaled down, they might have different scale factors, but they are similar by angle-angle. The correct answer here is C. Both of these are similar. I was about to say congruent. No, we're in Unit 4. All right. Let's talk about the side-side-side theorem. So if you have a triangle and all the corresponding side lengths have the same scale factor, again, that's just coming from this definition up here, if all of these fractions are the same fraction, then the triangles are similar. It's that easy. But you have to check all three, because typically what happens for your trick question is like this divided by this will be okay, this divided by this will be okay, but this one divided by this one is not going to be okay. It's like that last third one that doesn't work out, and they'll try to trick you that way. So you have to check all three of them. All right, and you have to do corresponding side lengths, which means you have to match the big with the big. It would be really silly for me to go like, that angle to that angle, or sorry, that side length to that side length. Well, no, that's the longest one, that's the shortest one. You always go corresponding. Longest to longest, medium to medium, small to small. Those are the way that you set up your fractions. I'm going to color code this very well. So this is going to be my blue triangle down here. And it doesn't matter which orientation, like is it going to be 6/9 or 9/6? As long as you're consistently doing one or the other, then it's fine. If you do blue over black, then keep doing blue over black, blue over black. Don't randomly go blue over black, then black over blue. That would ruin things. So I'm just going to randomly decide. I'm going to do blue over black. And I'm going to say 10, 6, and 4. Those are the side lengths of the blue triangle. And if I make fractions here, what color am I not using for this problem? Orange. Orange can be my, I want orange to be my fraction color. And let's see, what is the corresponding part of the long 10? 10 is the long 15, so I say 10 over 15. That must be equal to these other two fractions. This is the medium one, and medium goes with 9, so I write 9 here. The small length here is 4, goes with 6 and 6. So I've set up my equation. I have to check that all three of these are the same. How do I do that? Well, you just simplify. If you simplify your fractions, you're done. So when I do that, I can divide top and bottom by 5 here, and I get 2/3. Divide the top and bottom by 3, and I'll write my work. Divide by 5, divide by 5, divide by 3, divide by 3. 6 divided by 3 is 2, 9 divided by 3 is 3. Oh, okay, so far so good. Let's check this last one. Divide by 2, divide by 2, 4 divided by 2 is 2, 6 divided by 2 is 3, and hey, all of them are the same fraction. So we can say, we'll give ourselves a blue check. That one worked. Now we have to check the red one. All right, so I'm running out of room here. But again, I'm going to kind of draw all of these out, and I'm going to say the really long one is 16. The medium one here is 10. The next smallest one is 7. You can see that I'm going big, then medium, then small, just in terms of their numbers. If you ignore these triangles, cover that up with your hand, and only pay attention to the numbers are decreasing. I think that's a good way to set these up. Again, fraction, 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 all of these should be set equal to each other. All right, and again, what's the biggest number? 15. Biggest goes with biggest, so 15. Next biggest is 9, smallest number is 6. All of these fractions must be the same. All right, let's go ahead and reduce. You can't do that. The factors of 16 are 2, 2, 2, and 2. The factors of 15 are 3 and 5. There's nothing that can happen there, so that one's reduced. Can't do anything. 10 and 9, 7, 6, those are all coprime numbers. Coprime is a fancy way of saying you can't reduce them. So look, those are not the same numbers. 16 fifteenths is not the same fraction as 10 ninths, and those are definitely not the same fraction as 7 6. So this one is a giant no. Let me do a red X, or maybe I'll say no or something like that. Those fractions don't equal each other, so the only one that works is DEF. This correct answer is A. All right, that concludes our notes. Go ahead and give yourself a fist of 5 in your head. How well can you determine if two triangles are similar using the angle-angle theorem and side-side-side theorem? By the way, each of these corresponds to a homework assignment, so there's one homework assignment for angle-angle theorem, one homework assignment for side-side-side, for a total of 2 homework assignments tonight. With that, I close my notes. That concludes notes 4-2 for geometry, and I'll see you guys later.